My name is Daniel Myers, lead developer advocate here at Snowflake. And today I'm really excited because I'm going to be showing you step by step how to build a data application with Streamlit, Snowflake, Snowpark, and data from our data marketplace. It's going to be very much hands-on with the intent that you are able to do exactly what I'm doing. We're going to be building an end-to-end application with data from our data marketplace and Streamlit. Let's get started. So a quick intro about me. I'm a lead developer advocate here at Snowflake, where I've previously been at companies like Google, Cisco, and others. I've helped found different startups here in the tech space. I have 3 patents with a background in computer engineering. So a quick overview of what exactly this lab entails. Let's go step by step over this. First and foremost, we're going to show how to consume data sets in the Snowflake data marketplace. We're going to also show and actually perform queries on this data from the data marketplace in Python using data frames. That's specifically from Snowpark, right? So our Snowpark Python library. We're going to utilize third-party existing Python libraries in this code as well. This is all part of building that broader data application and working in that software ecosystem. We're actually also going to be creating a Snowpark Python user-defined function in Snowflake. This is key because that means that the compute is not running on your laptop. It's actually running inside of Snowflake, meaning that you get all of the scalability and the power that Snowflake can provide out of the box. And lastly, we're going to actually create a data application with Streamlit to visualize all of this data that we're working on from our data marketplace in Snowpark. With that, let's do an overview of these 3 big elements. Really, it's all about Snowpark, Streamlit, and the Snowflake data marketplace. And so what is Snowflake? From a developer and data app development perspective, Snowflake is really the developer platform for building all things data related. So it's a unified global system for connecting your data with your other applications, with other businesses, with your users. So no matter where your data is located, no matter what format that data is in, you should be able to ingest it, analyze it, take action on that data, all within Snowflake. So what really powers Snowflake is our unique architecture, which is really comprised of several different layers. At the most basic first layer is our cloud agnostic layer. This is very important because cloud agnostic, meaning we can run across all 3 major cloud providers, Google Cloud, AWS, and Azure. What I mean by that in particular is that when Snowflake is running on that particular cloud provider, we are using that cloud provider's native technologies and services. So you're on AWS, we use S3. You're on Google Cloud, we use Google Cloud Storage, which then actually brings me to the next layer in this architecture, which is the centralized storage layer. This is really where you start to see the power of Snowflake in that all of your data can be centralized so you have a single source of truth. You can ingest data directly from S3, directly from Azure, directly from Google Cloud, and be able to scale this data layer, this storage layer, independently from the compute layer. That's very important because different applications have different scaling requirements. Some apps have a small amount of data, but they operate on that data. They query that data huge amounts. So their scaling requirements is that they need to scale compute more than they need to scale the amount of data that is in that application. Whereas on the flip side of that, some apps have an immense amount of data, but they don't do that much querying of it. It's more about the storage and so that they can query it when they need to. And so they want to be able to scale that storage layer to massive amounts while not necessarily having to over-provision their compute layer. And this is what brings me to the next layer here, which is that multi-cluster compute. So in Snowflake, we call the compute layer warehouses. You spin up a warehouse, very similar to a VM or just a general compute metric for how you measure and scale your compute in Snowflake. And what's unique about this as well, what doesn't click for a lot of folks instantly, is the need for scaling compute separately from other compute. What do I mean by that? Well, let's say you have a production application. This is the main app that your customers are accessing on a day-to-day basis. But your finance team also needs to be able to access and run queries, ad hoc queries, on the payment data that's coming in live from your production app. You don't want those ad hoc queries from your finance team impacting the production systems. You don't want that level of compute to slow down anything or really have any impact at all on that production application. With Snowflake, you can do that. You can actually spin up dedicated warehouses, again, dedicated compute, for different teams within your organization, even different applications. And what that ultimately means is that you have consistency for that particular use case that is immune from service interruptions from other compute and other teams that may be accessing that same data. That's the other important piece here, is that all of these separate different compute elements can access that same centralized storage layer. That's important. Now, when we go one level higher, the cloud services layer, this is really where the brains and some of the additional things that Snowflake does that's special on top of the compute and storage layers. That is things like our query optimization, data management, transactions, all of the metadata that you have, even the sharing and collaboration of that data across organizations, across other teams. So this is that RBAC control, role-based authentication that you can implement with Snowflake, things like that. And so altogether, this is the Snowflake architecture that powers this global unified network of data that you can build applications on top of. Now, let's look kind of one step closer to what it means for developers and specific developer considerations on a data cloud platform like Snowflake. First and foremost, any data cloud needs to have all of your data, no matter what speed, no matter what format that it's in. It needs to be able to ingest that data. You need to be able to query that data, analyze that data, and do something with that data inside your application. So with Snowflake, you can do all of that. You can have structured data. What do I mean by structured data in this case? It is your SQL, very structured table formats, where you have columns, rows, you specify your column type, etc. We support semi-structured data, which are things like JSON, Parquet, Avro, XML, others. We even support what we call unstructured data. That is raw binary, something like PDFs, videos, JPEGs. A data cloud platform needs to support all of those structured, semi-structured, and unstructured data types to where you can simultaneously query all three of those data types at the same time. For example, at Snowflake, you can literally create a query that takes a SQL table, joins it with semi-structured JSON documents, and even extracts text from a PDF file all together in a single SQL statement. That is incredibly powerful and something that for a data application is very much needed. So the second big consideration that developers have when looking at a data cloud platform and developer platform for data applications is that you almost all the time have an existing app that you're developing against, and you need to be able to code using that same language, same programming methodology, same architecture that you have, and you want to add Snowflake to it. And you're doing it for a certain reason. Either it could be because of certain features that Snowflake has, because of the performance that Snowflake has, or the cost benefits. And so all of those, you want to be able to leverage the same language and coding that you're familiar with. So what's really cool with Snowflake is that out of the box, we support a wide variety of language native SDKs. Everything from Python, Node.js, Go, .NET, PHP, you name it. We have a very large number of language native first-party SDKs that you can get started with today. And what I have a picture of here is Snowpark, which is one of our latest developments all around how to leverage both your client-side application, whether that's Scala, Python, Java, or others, but leveraging the Snowflake processing engine. This is what we're going to be using today in the lab. And so with Snowpark, you get to leverage the power and scalability of Snowflake because your code is being deployed and run on inside of Snowflake when you develop it locally. Really cool stuff. So the third big consideration that developers have when choosing and using a data cloud developer platform is where and how you create your dev environments with real data. So as a developer, it's always important that when you're developing and using your development environment, that you are developing against real data, whether or not that is data that you've generated based off of real data or using the same format, things like that. You need to be able to test with your CI/CD environments against these real test cases. With Snowflake, we have a feature called zero copy cloning. This is hugely powerful for developers because what it means is that you can have a real live pointer to production data in your dev environment, but where your dev environment does not alter or modify that production state. What do I mean by that? It means that you can have and develop against literal production data inside of your testing environment, for example. It also means that third-party ad hoc teams can have pointers to that production data in real time with the zero copy cloning capability and not affect or modify that production state. And so what is zero copy cloning? It is providing pointers to actual data on disk without actually duplicating that data on disk. And so the possibilities of what you can do with that are pretty powerful. And this is actually the technology that powers Snowflake's own data marketplace. So when you are purchasing data or using free data from our data marketplace, under the hood, it's using zero copy cloning to give you access to that data. Really cool, really powerful stuff, especially for developers and the speed for developing new applications with real data. Which brings me to one of the last considerations for developers, which is getting that instant access data within your application. And specifically for our data marketplace, which again, we're going to be using the data marketplace today in this hands-on lab. So there's no ETL, there's no API needed to access the data. It's just presented literally to you as an object in Snowflake, ready to query instantly. Really cool, really awesome stuff that's powerful, makes it way easier to develop applications on Snowflake. It also means that it's automatically up to date. What's really cool, a lot of people don't realize this, is that you can even share different compute-styled objects. So for example, UDFs or external functions. So not just the actual data that's sitting on disk, but you can share and monetize functions, for example, that do things on the data. And so this gets even more powerful with things like what we announced earlier at Snowflake Summit was native applications, which is a whole framework built around this secure data sharing, being able to share applications with others directly on Snowflake. So let's start and go over the things that we're going to be using in the lab today. So we're going to be using Snowpark, the marketplace, and Streamlit together, all three, to build a data application. With Snowpark, there's two big pieces here. Snowpark itself is a SDK and set of APIs that you leverage, that you can program in a data frame style environment for Snowpark on the client side that is then run and deployed inside of Snowflake. So this means you can write in Python, which is what we're going to be doing today in our lab. You can write your queries in a data frame style programming with all of the benefits that data frames provide you, while the actual Snowpark library that you import in Python converts that data frame into a SQL query and makes it run and get deployed inside of Snowflake. So really cool. It gives you the power of Snowflake and the scalability of those warehouses that compute while also operating on that separate centralized storage layer that we talked about earlier. So let's take a quick look at how Snowpark works. We're going to be using this to first import our Snowpark libraries. So from Snowflake, you see that in the first element here, where we are importing Snowpark, we're importing Snowpark functions and types. And so what we do is we create a data frame, DF, that is a mapping essentially to a table of products, and we filter on the ID. So ID equals 1, which maps directly to a SQL statement, which is select star from products where ID equals 1. So this, in a nutshell, is what's going on behind the scenes for Snowpark and what it's actually doing to your code and how it runs on Snowflake. So with Snowpark, you get a few big benefits. One is that streamlined architecture. Many developers today are already using data frames because of their extensibility for other platforms, other libraries. And so when you have a data frame for Snowflake, for example, you can run that inside Snowflake. And so you can collaborate on the same data in a single platform. You can also build scalable and optimized pipelines. Because these are getting translated directly into SQL statements that run on Snowflake, that means the Snowflake's optimizer behind the scenes is crunching that SQL statement. You get all the power and benefits that Snowflake provides, constantly improving performance of these SQL queries on your data. It also means that you can act with confidence because with Snowflake, you get enterprise-grade governance. That's that RBAC control. You get that data governance with setting up users, grants on roles, things like that. And it also means you get the security across all of your workflows. When you are using just one set of governance policies, it's way easier to, one, identify and check all of your different security areas when developing an application. Let's look at a mental map here of how this is running inside of Snowflake. So Snowpark itself works on top of Snowflake's engine. It makes it easier for developers to develop against and work with Snowflake. It's extensible in the fact that you're plugging into Snowflake's compute engine. It makes it so that Snowflake itself is doing that compute instead of your local machine, for example. Whether or not that's the JVM, different external functions, JavaScript, for example, all of that, your Snowpark elements are being deployed and running on Snowflake. So let's take a look at the next big element of our lab here today, which is the Snowflake Data Marketplace. This is really the central area for you to discover, purchase, or even get access to free data that is available to you directly within Snowflake. We have tons of different categories from business to energy, financial, different marketing data, sports data, travel data, even weather data. All of this data is available to you on the marketplace through just a couple clicks. With this, there's no API integration needed. There's no ETL. You don't have to extract this data from a FTP server somewhere, create a mapping to transform it into your schema. It's just there. That's the beauty of the data marketplace is that one, all of the data that is there, so the actual content, which is vital, but also the fact that as a developer, when you access that data, it is just there as if it's another object in your Snowflake account that you're ready to access and ready to query. Really powerful. One of the coolest things really about Snowflake. What's even more powerful about this is that you can be a data provider, right? So you can obviously submit your own data to the marketplace and either sell it, make it available for free, etc. So you can monetize your data on the data marketplace. You can also share access to your business ecosystem. So you can create private shares with other teams, just as if they were accessing data within their own systems. You can also share data with other companies, so your customers, for example, that are not yet on Snowflake. And you can actually do that through managed reader accounts. This is where you set up a Snowflake user in your own Snowflake account that has read-only access to the data. Lastly, you can also analyze this data without having to expose it. So this is that private share capability. So you can privately share this data with one of your customers without exposing it to the broader internet and things like that. No ETL required. It is cross-region and cross-cloud, and it's live, ready to query. This is one of the most powerful aspects of Snowflake today. So I mentioned today that the content is a big piece of the data marketplace. And with the data marketplace, we have today over 260 providers in over 18 different categories. Everything from our Snowflake customers can access that data, and hundreds of applications powered by Snowflake members, which are companies that are building their customer-facing application directly on top of Snowflake, run today in Snowflake's data cloud. So really powerful stuff. And we see that by our ever-expanding marketplace. So these are all companies that list their data directly on our marketplace today. What's cool is like everything from ADP, FactSet, Heap, HubSpot, ZoomInfo, Equifax, and others. So really cool to see the growing usage of the Snowflake Data Marketplace, both as providers, but also for consumers of data to be able to get and access that data directly within their own Snowflake environment. The last segment of this hands-on lab, before we actually get to the juicy code, is Streamlit. Streamlit is an open source Python library for quickly creating interactive apps. Okay. So this means that you can create a web app entirely in Python. You don't have to know HTML, CSS, or JavaScript, but you get all of the benefits of those things out of the box. So you get that interactivity that you get with a typical web app, but you get the ability to develop it all in Python. And so it's a new way of directly creating apps with Python for the web. And there's really three big use cases for Streamlit today, which is one, doing data science. Because it's all in Python, it makes it really easy for data scientists, ML engineers, data engineers, and others that have pre-existing Python knowledge and experience to build these full-fledged data apps with Streamlit. That's really cool and really powerful. It also means that you get to code in Python. And especially when combined with Snowpark, everything stays in Python. You get that data frame style programming inside Streamlit. It's a really exciting combination. And then lastly is looking for speed. What do I mean by that? I mean, you can go from no app at all to a full running application with a URL that you can share with others in literally minutes. You don't have to have that front-end development experience in order to create Streamlit applications. And that's a powerful piece of this. And what makes it so exciting today, because it's so quick and easy to do this, it means rapid prototyping, demoing of work, and creating tools for business users are three of the biggest use cases that we've seen today of Snowflake customers using Streamlit within their businesses. And so one of the things that you'll see out of the box is that Streamlit is used by tons and tons of developers today. In fact, it has over 10 million downloads, over 50,000 active developers, and even 50% of the Fortune 50 use Streamlit today somewhere in their business. So really cool stats here, all about Streamlit and being able to use it to develop data applications. So today we're going to be using specifically Streamlit to install the open source Python library. We're going to connect Streamlit to Snowflake via the Snowflake Python connector. We're going to build this Streamlit application locally right here on my laptop right now. And we're going to deploy it and share with others. So you can do it on your own laptop and share it with your friends as well. And so why does all of this matter? It means, one, we're going to be doing it all in Python. You only need Python to develop this application. That's it. You can explore your data that we're going to be accessing on the Snowflake Data Marketplace, and you'll be able to directly share that application with everybody so that they can actually see and visualize this data of this data application that you created. So with that, I'm going to close out of this slide deck and let's go to VS Code. Inside VS Code, what I have here right now is my Snowpark Streamlit app. It's a Python file that has all of my source code here where I'm doing all sorts of cool stuff. I have it running currently in my terminal. So you'll notice here I have my Streamlit. I can access it directly in my browser. And so what I'm going to do is Alt-Tab back to that tab. So this is the application that we're going to be creating today. So the actual story here is we want to predict the inflation. Inflation has been crazy high this year. right? Let's actually use data from our Snowflake data marketplace to predict what inflation could be next year. And so what data are we going to be using? We're going to be using the economy data atlas from the data marketplace. All of this, by the way, is viewable here. So we can select the year. So this is all interactive. We can select the year to see the price indexes for personal consumption on a per year basis. And you'll notice it's running there. So this is goods. The goods price index was negative in 2019. It looks like the recreational goods and vehicles was negative as well in 2019. Let's take a look at like a more recent year, like 2021, which was, for a lot of intents and purposes, a very good year for the stock market, things like that. Let's take a look at how some of this inflation numbers happened in that year. So we see a lot of stuff was up, only a few things were down. And you'll notice here the personal consumption expenditures per year as a whole goes up over time, right? And so let's actually take a look at where this data is coming from and how we are able to predict future years based on this data. So first and foremost, all of this hands-on lab material is available on quickstarts.snowflake.com. And that is what I'm going to be going over step by step right now with you. To get this exact one that I'm going to be showing, just type in Snowpark at the search bar, and you'll see the second one that's there is building a data application with Marketplace, Snowpark, and Streamlit. So I'm going to click on that because this is what we're going to be going over. So inside this quick start, what's cool about it is that there's only 6 total steps to complete this entire lab, which is really encouraging, really cool to see. And on the first step, we really go over all the elements that are required to actually complete it. A few of the prerequisites that we have here today is, one, you need to have at least a Snowflake trial account that gives you that account admin. You can sign up for free entirely. It's a 30-day trial directly from Snowflake. Or if you have an existing Snowflake account, you can use that as well. You just need to make sure that you have account admin access in order to install or get access to that marketplace data. Account admin is needed to install or get access to marketplace data in general. It's going to be good to know and have a basic knowledge of SQL with this because we're going to be using SQL to set up the environment, things like that. You do have to at least have Python installed. And this whole thing runs in Python, so you will need to make sure you have Python installed and the ability to run, software on your computer. So if you are running on a corporate environment that limits, what you're able to install, make sure you check with your IT department to get the proper permissions on your local laptop. I will be using VS Code today. And so all of the instructions here today are leveraging VS Code to run this application. And so if you have VS Code installed, definitely use that. Today, what we're going to be going over in short is we're going to be, like I said earlier, consuming data sets directly from our data marketplace. We're going to be using data frame style programming directly from our Snowpark libraries. We're also going to be importing a few existing Python libraries from third parties. And we're going to be visualizing everything that we're doing using Streamlit. Let's go ahead and get started. To prepare this lab environment, we use Miniconda. Now, you can install it right now if you'd like, by clicking on this link. And it brings you to this page here. Let me make it a little bit bigger so we can all read. And so you can download it from any of these links here. I already have it installed. I'm running an Intel Mac, so I would install one of these for myself. If you're running Windows, you can use that, or Linux. Make sure that if you're running an M1 or M2 Mac that you use one of these. Miniconda is great. You can also install the full version of Anaconda. Either one is fine. It'll work for both. So let's go back. What we are going to need to do here today is open the command prompt. We're going to create a new environment with Conda today. So let's go ahead and do that. And so I'm going to open up my terminal here. We're going to install a few things. Let's go ahead and let's do cd repos. Let's do build lab 2 live. And so in here, I'm going to cd into that, and I'm going to do this. I'm going to rename mine in particular to a different one, just so that we have it here, Snowpark Live. And what you'll notice when I do this, right, is that this command does a couple things. One, it's going to ask me and make sure that I have all of the proper Python packages and libraries installed. So I'm going to proceed with yes. It's going to set up and install a few things for me. So what is Anaconda? It's a lot of things for one, but one of the things that it does really well is environment management. So what we're doing ultimately here with this command is we're creating a new environment. We're calling it Snowpark, and we're using Snowflake's environment and basically leveraging that exact environment so that we can have and run everything according to that. And we're doing it specifically with Python 3.8. Once everything is installed, we're going to activate this Conda environment by running this command. So let's see if this is done. Looks like it's already done, so that's awesome. So and look at that, it already gives me the thing. So let's go ahead and activate Snowpark Live. Let's do that. There you go, and you'll notice my terminal prompt has changed a bit. So now it was base, now it's Snowpark Live inside my directory here. So activate Conda environment, that's what we did. We're going to Conda install pandas. Okay, so let's copy and paste that. Let's do that. Might take a few seconds to download and install. Make sure that when you run this new install command, that you're doing it inside that environment. So the order of operations here matters. You have to first create the environment. You have to then activate that environment. And then once you're inside that environment, you can then do the rest. So you're going to install pandas, you're going to pip install Streamlit, you're going to pip install this and go from there. So the order of operations is important. So we can see here, it's already done downloading and installing the Conda install pandas. So that's awesome. Let's go ahead and do the next, where we'll do pip install Streamlit. Let's do that. Take a few seconds to download and install Streamlit itself inside. And what's cool too, so one thing that you might run into, okay, is it might ask you, hey, we're missing some further up dependency. Do you want to install that? Because I have already installed all of these, so it already has every single dependency necessary to install these dependencies. So if your particular environment comes back after running one of these commands saying, hey, we're missing this library or this thing, just do pip install whatever it is that it's asking for. And then rerun Conda install pandas, for example, pip install Streamlit. And that'll get you past that. I'm going to do this one now. Let's copy and paste that. And there we go, already done. Successfully installed all of that. And so now the last thing that we're going to do, we're going to install Snowpark Python. Let's do that. Proceed. You can see it downloading. Thankfully, I am on a gigabit fiber connection, so it goes fast. So there we go. It's already done downloading. It's executing the transaction now. And once it's done with that, I will go ahead and show you these files here. So if you go to this link here, what it'll do is it'll bring you to this page here where you can download, and I'll make this a little bit bigger so we can all read it, where you can download all of these files. Just right-click download. And so I've already downloaded these, which is great. And I will show you to them here. So these are the three files here. We have a few different ones. We have the Jupyter notebook that initializes, imports the libraries, creates Snowflake connection. We're going to be running through every step of this notebook. And it also contains those three files. One is the Streamlit application. Okay, so this application is what actually creates and is running right now this page here of Economic Data Atlas. So when you run that Streamlit app, this is what actually gets deployed and is running on your local laptop with the queries, Snowpark running inside of Snowflake. So really cool stuff. And then the last file is the setup file for Streamlit, for all of the summit data, creating the stage, and setting up the economy data atlas, data from the data marketplace, as well as the prediction UDF we have as well. So let's go back and look and see if this is done installing, and it is. Fantastic. So let's go back now to this quick start. So we've gone through this entire step 2. We've installed Miniconda. We've gone through and created the environment. We've activated that environment. We've installed all of the various dependencies, and we've downloaded the various lab files. So let's go ahead and go to the next step. So for step number 3, we need to prepare the Snowflake environment. And to do that, there's a few things that we go in to Snowflake itself and do. First of all is actually getting the data from the data marketplace. In this case, the economy data atlas is what we're going to be getting from the data marketplace today. And remember, in order to do this, you do need to have account admin access. So if you have a trial account, you'll be set up right off the bat. So let's go ahead and do that right now. So I'm already logged in to Snowflake here. I'm going to go to Marketplace. From here, you'll see a couple things. As it loads the Marketplace, there's a couple things that we'll see. One is the Economy Data Atlas, which is one of the most popular ones. I'll click on that. You'll notice I already have it installed. So these are some of the example queries that we're able to do with this data. With this data, you can see fields include real GDP growth, the inflation rate, unemployment rate, productivity, etc. So there's a lot of really good data here that is professionally maintained that we get real-time access to. To run some of these example queries, let's go to one of my worksheets here that I already have set up. And let's actually run, for example, this query here. And what you'll notice is that when I do that, you'll be able to see all of the information from the full table name, the table unit, the indicator, the units, the scale, all of this information, and ultimately the value for that row, all located within this example query for price indexes for personal consumption expenditures by major type of product. And so we're going to be using this information within our Streamlit app. So now that we have this data installed into our Snowflake environment, an example query on the data, let's go back to the quick start and see what's next, right? So this is the query that I ran here. And so if you haven't already, what you'll need to do is make sure you set up a few of the other elements, which is setting up the database. So create database if not exists. You're going to be creating the UDF stage and things like that for getting, what is the inflation over time? This is the query for that. And so this actually sets up a couple objects within your Snowflake environment. At this point, we're actually on step number 4. And so we want to start exploring the data inside of a Jupyter notebook. And to do that, I will go to my VS Code. And let's go to here. And so what I have set up is this Jupyter notebook. Let's kind of zoom out just a little bit so we can see more on the page. But you'll notice a couple things. One is within this Jupyter notebook, I have set up my Snowpark Conda environment. So that's going to be important. So like from here in VS Code, you'll want to make sure that you have your correct environment set up. And then from here, you should be able to make sure you set your connection parameters for your account locator, your username and password. And always keep in mind to get the account locator. one easy way to do that is if you're logged in to Snowflake, you can get it here and be able to get your account locator by clicking on this button here. And so what we're going to do now is run a few of these segments. So I'm going to sit here, run this. And what this is doing is it's going to initialize the notebook, import all of the necessary libraries, which is what it's doing here. It even imports Streamlit, pandas, etc. And so you'll see here, what's cool is at the end of the day, it gets the context that it has from within Snowflake. And so now let's do that same query that I did inside Snowflake. Let's do it inside this notebook. So to do that, I can click on this button here. After just a couple seconds, it gets the data. And so to get a better view of this, let's zoom out a little more. And there you go. So you'll see that it's in table format here. And it has that value information as well. All that same data that I just showed directly within Snowflake, you're now able to do it from within a Jupyter notebook. That's really interesting and really powerful. Let's zoom back in so we can actually see some of the text. So this next step that I want to show is, as part of this lab, is actually setting up the data frame. With this, what we're doing is from the session object in the table, we're creating this SQL query using data frame style programming. And so if I click on this and run it, what you'll notice is we get that same data back. But now it's done entirely through data frames. So that's another really powerful mechanism for developers, data scientists, data engineers who are more familiar with data frames in Python than necessary SQL. So you get, the same filter, the column, and things like that using data frame style programming. So let's take this one step further and actually show let Snowflake perform the filtering using Snowpark pushdown and display results in pandas data frames. So let's actually run this piece of code. And what you'll notice, this displays it in nice table format. You'll see this is now the data frame. And what we've done here is use the data frame select and the year with different column alias. Ultimately, we're doing it to pandas. And so when we do that, you'll get this data back from Snowflake. And what's powerful about this is that this is doing that Snowpark pushdown, meaning that you are running this on Snowflake and being able to get the power and scale that Snowflake provides out of the box. Now, let's take this even one step further. So we're going to train a linear regression model using all of this data. Let's run this. It takes just a couple 0.3 seconds. And when we do that, we train this, we get the prediction year that we want, and we go from there. And you'll notice here are the various predictions. For 2021 is 116. Let's even test it for 2023 and see what it thinks about that. Well, if we run this now, you'll notice for 2023, it thinks that it's going to be 119. And so pretty cool stuff. Let's actually take this to the next step, which is creating a user-defined function within Snowflake to do the scoring. Okay, so when we do that, we're creating or defining a function here that returns model.predict, gives you the prediction year, it rounds it, and casts it as a float. Let's run that. And so, you'll notice here it's registering this UDF. So it's deploying this UDF into Snowflake. And you'll notice that it does that inside the stage that we have here. And this is where we're importing those packages. We're specifying which packages are needed to run this function. And so you'll notice it took about 10 seconds to run. And so now it has been deployed and registered on Snowflake. And so now in our next step, what we'll be able to do is run that exact function that we registered within Snowflake. And so you'll notice 2023, there's that 119. So there it is. So it does that same thing, but now it's registered as a function, and you'll be able to leverage that function in future SQL queries, combining that function with other functions. Everything that you can do in data frame style programming, you can now do with Snowpark as well. So let's go back to the quick start here, right? So let's review step number 4. When I went to VS Code, I made sure that I had my environment set up, right? So I had that Snowpark environment already configured, and I selected that. I initialized that notebook. So I ran through that initialization step in the Jupyter notebook, where it actually connects to Snowflake. And this is where you have to specify those connection parameters, things like your account, username, password, which warehouse and role database schema that you're using. As we move forward here, you'll be querying the data using a SQL statement with the Snowpark data frame. You'll be setting up the Snowpark data frame like this. You can create features for ML training like we did. And you'll be able to train the linear regression model with Snowpark. And then you'll be able to create a user-defined function in Snowflake with the trained model, right? So this is where we registered that UDF. And then in the last step, we actually call that UDF directly from the session here. So this shows how to use Snowpark within Jupyter Notebooks, and you can do all of your data science work with the power and scalability that Snowflake provides out of the box on your massive amounts of data. And so for step number 5, we're going to actually be creating that Streamlit application. Now remember, this is that web app that I showed you earlier. This has things like the personal consumption expenditures price index over time. So we see it by year and how it's changing each and every year. We can scroll down and see by different expenditures from healthcare to household consumption to utilities, how that changes each year. So we can modify this drop down, select a specific year, and it grabs it again directly from Snowflake. And remember, all of this is being used by that Snowpark Python connector and Streamlit. And so let's go back to this and see what all we're doing to create this Streamlit application. And again, entirely in Python. You don't have to know HTML, CSS, or JavaScript to get that level of interactivity for your web app. And so what we see here is we're going to be importing the required libraries, just like we did before. So Snowpark session, Snowpark types, functions, our pandas, and Streamlit. And so we're going to be setting the application page context. This is things like the page title, page icon, what layout we want. Then we actually connect it to Snowflake. This is where you have to create that session object again, just like we did with the Jupyter Notebook. Things like your account identifier, username, password, warehouse role, database, and schema. And so from here, you can actually test and make sure that your connection is correct and it's actually able to return a session by doing something like this. And you can return and print the current warehouse, current database, and things like that. And ultimately, it will return the session object for you. And so let's take a look and see the code here for this Streamlit app. So you'll notice that I have a couple things. I have, again, those imported libraries, very important. That page context. I have created my session object. I have my session parameters here. And I do exactly that. I create that session. I get the current information, current warehouse, database, etc., and I return that session object. Now, what I do next is I load the data. So from here, I have that session, I pass that session in, and I create that same Snowflake data frame from before, from the Jupyter notebook. So I have this economy data atlas data where I'm getting the price indexes for personal consumption expenditures. I'm filtering it based off of the indicator name, the frequency, and the date. And so I'm doing all of this. I'm selecting the columns. I round to the PCE series. I convert to Panda data frames. And then ultimately, I create the metrics. I'm going to be using these metrics later on in the application. And so all of this is getting all of the data from Snowflake into this Python Streamlit app. And ultimately, what I do is I get the data per quarter. I combine actual predictions of these data frames. And then I show this here as graphs. So what you'll notice is, how do I actually display it as a graph? Well, what you'll do is ultimately you add those web page components. So this is the part where you add the header. So you'll notice economic data atlas. So you'll notice personal consumption over here is a header, and I'm adding different explainers, subheaders. And this is now where I go in and add, for example, the select box. So selecting a year. So in this case, what I'm doing is I'm grabbing the years that are available, and I grab them and show them here, select the year. So this is that select box component from Streamlit, and I'm doing it here inside the code. And so all together, we're able to create a full-fledged end-to-end web application entirely in Python using data from Snowflake and combining that with the power of Snowpark to do things like the training and calling UDFs directly from Streamlit. So really powerful things to be able to do. Now, to actually run the application, you can do that using this command, Streamlit run, and you supply the name of the file that we just were editing. And so I have mine already running. So let's just go ahead and close it. So I'll show you exactly. I do Streamlit run my Snowpark Streamlit app. I can hit enter, and it's going to spin up. And so you'll notice here it goes. It automatically opens the web page for me, and off it goes. And so it has all that data from Snowflake. It just queried it all directly from Snowflake and displaying it on localhost port 8501. This is where you can do local development in Python. And then with Streamlit, Streamlit has a thing called Community Cloud. You can actually directly deploy this and share a public URL with others on Streamlit's Community Cloud. Really cool. And it's a really great way to share your data science, data engineering work with others on the internet. So don't forget, in order to run that, you will need to make sure you have activated that Snowpark Conda environment, which I did here. So if I close this again, you'll notice I have that Snowpark environment already configured. And so in the application, it shows exactly what we were doing. So really cool stuff. And that's it. We just completed the end-to-end lab. Hey folks, thanks for watching here today, where we've been able to get hands-on with Snowflake, Streamlit, Snowpark, and data from our data marketplace. To review the exact steps that I've gone through here today, be sure and check out the Quick Start at quickstarts.snowflake.com. You can also download additional developer resources at developers.snowflake.com. You can also get connected with the rest of the Snowflake community at community.snowflake.com. Now, last but not least, be sure and smash that like button and subscribe for future videos. My name is Daniel Myers. Thanks for watching.
Snowball fight! Wow! You really stepped up your game! I've been using using Snowpark, silly. It lets you build snowballs with confidence by removing data security and compliance barriers to production with consistent enterprise-grade governance controls. Pretty cool, right?
Wait, what?
Frosty gets his own song. Why aren't we singing about Snowpark? The easy way to production for Python. Using pre-installed packages and automated dependency management and secure processing. How do we make that rhyme? Oh yeah, speed! Woo! I built this myself. Nothing could go wrong. Oh no! Ah!
You didn't use Snowflake Snowpark. It's the only way to go. Woohoo! I'm going so much further. Eat my snow!